All of the lights in my house are wrong. Too blue, too bright, or they flicker. And when it's 10 p.m. you're trying to fall asleep, none of that is what you want. The light I actually wanted, warm like a candle, no blue, smart, and no flickering, does not exist anywhere. I looked. So I built it myself. This is a story of how, and along the way you'll learn what I learned about driving LEDs, PCB manufacturing, and 3D printing.
Yeah.
So let's go.
Yeah.
Shoot you, baby.
Yeah, looking for a lamp, just a lamp, that's all. No flicker, no blue, just hammer on the wall. World didn't have it, not on any shelf. So I said, fuck it, I'll build it myself.
When you look for cozy evening lights, you'll get something like this or like this, a 2700 or 3000 Kelvin light. And to me, it's warm white, but it's not candlelight fireplace vibe. It's pretty much impossible to find anything warmer than this. Maybe you say now, yeah, but RGB can make any color, right? Yes, but it brings its own set of problems. So let's have a quick look at the color science. You see that the sun emits all the spectrum, all the colors, and there's a lot of red in there. If you look at a cheap white LED, it looks something like this. There's a peak in blue, and there's a little bit of yellowish orange tint to kind of, when we look at it, it still looks like the same color, but to our nervous system, it is not the same thing. When you want a light in the evening to help you calm down, you cannot do it with a cheap white LED because the spectrum is just wrong. You can do an RGB LED, and you might say, well, there's not that much blue in here, but the other problem of this is color reproduction. When you shine it on other things, they look different. So when you look at your partner, it's like, what the fuck has happened to your skin? It looks so dead. And that's because the spectrum does not match up sunlight spectrum. And this is why I have a very specific LED type that I want, because I want the health benefits. I want this to help me during the evening to fall asleep. I have a full video on light quality, so if you want to check that out, look at that video. For now, these are the most important bits for you to understand, and that means that we can move on to electronics. So here's what I want. I want an LED, 1800 Kelvin, something like that, full spectrum, so no blue light allowed. Dimming should be analog. There should be no flickering going on out there. I want it to connect to my smart home, so we'll need some kind of Wi-Fi connection. And then it needs to have a clean, beautiful housing. I've never done 3D printing, I don't know how that works. USB-C power, so I can just use it with my existing chargers. I don't have an electrical engineering degree. I have an engineering degree, so I know some things, but we're just gonna have to figure this out and buy all this stuff and then see if it actually ends up working. I think I'm gonna have to use a ton of AI. I knew one thing, and I knew one thing very well. That's which LED do I want. I already knew a manufacturer, LC Focus. They actually sent me over their test reports. If you look at the spectrum here, dude, that's excellent. They have a few variations. They have a 3 watt, 10 watt. So one of the questions I had was, which one do I need? And I'll ask for Claude to figure that out. And this is where I had the first great surprise. USB by default can give you 5 volts and like 1 or 2 amps. If you want more than that, you need something called USB power delivery. If I would get a 3 watt LED, it turns out that this 5 volt standard stuff is plenty. So to start off, I thought, let's just order the minimal set of components so I can test this out. I ordered the LED, I ordered a heatsink, and then I realized I made a mistake. When I got these lights and I looked on the packaging, I saw 80 to 90 lumens. I'm like, that's like nothing. That's not gonna be enough. Dang, I'm gonna have to get the 10 watt instead. But I couldn't test it because I also realized that it just came like this. A little LED. There you go. I can't put this on the heatsink because I need to connect them electrically, the plus and minus, to here. And if I put it on the heatsink, it'll connect it to the heatsink electrically, and that's just gonna short circuit. But then the 10 watt thing, I'm not gonna be able to cool it with the same size heatsink. I need heatsinks that are bigger, so I also ordered bigger heatsinks. But then I got everything and I could test it. And then I saw that this 3 watt LED, they are really, really bright. I don't need the 10 watt stuff. So with all these ingredients together, I went to Claude and I said, please make me the diagram, like what components do I need? I thought it was gonna be, you got the little USB port and then you connect it to like the microcontroller and you also connect it to the light and then it just kind of works, right? It turns out it was way more complicated than that. I copied this into ChatGPT and I told it, this is my plan. Where is it going to go wrong? Then I got that result and I pasted it in here. And it's like, okay, yeah, it's correct. It's like, forgot all of these things. So this is not going to work. Oh, it's a conductor, not an inductor. Yeah. And so I did this, it improved it. And then what I did was I did the same thing again. I went into ChatGPT, new conversation, asked the exact same question. And I went back and forth like 4 or 5 times until the point came where they were both like, yeah, it's gonna work. Maybe this is a slight improvement. And then Claude was like, yeah, this is a little bit too much, right? So let's just chill out. Now we can start building this, getting it so that we can manufacture it, send it out to JLCPCB to make the circuit board. But first we needed to put the circuit inside of KiCad. So I switched to Claude Cowork, which can make documents for me, and I asked it to make a bill of material, a BOM for me, so I know which parts I needed. And I also told it, like, can you please like make me a step-by-step guide on which things I need to connect to what. And it just keeps going and going and going. I'm like, God, this is insane. Like, am I gonna do this? I mean, there's so many, like one mistake and nothing works anymore. I was like, okay, well, I guess I'll try. And I did. So I followed the steps. I implemented it in there. So I made a diagram. And then the diagram was done. But the challenge is not over yet. Because once you have the diagram, you know which components you have and you know how they should be connected. But you haven't placed them on a circuit board. And that's the next big challenge. So when you switch over to the circuit board, I mean, you see the final work here. This is what it ended up. But this takes so much time because you have 2 layers of wires and wires cannot cross. So that means that you need to think about which wires do I draw first? Which can go around the other way? Then you have a second layer, so sometimes you can go to the bottom, you can go through it and go back up with your wire, but you don't want to do that as often. Then there's a challenge of preparing this for manufacturing, and they're going to tell you a whole bunch of things that are wrong with it. It's like, oh, this hole is too small, this thing is too close to the other. And so you go back and forth doing this and seeing what you can fix in KiCad by moving things around. And it says a bunch of green, but also a bunch of error. Like, oh, the text that you're printing here is too close to the hole you're making. There's also a whole mess with sourcing all of these. So this is a component, it needs to reference something that you can buy on JLCPCB so that their machines, take it from stock and put it on the thing. And so the thing Claude says does not exist. I need to search for it. Every component on there, you have to tell Claude, dude, look this up, read the PDF, and make sure that your numbers are actually correct before you're telling me what to connect to the other thing. Again, one mistake here and nothing works. I actually had this almost happen to me. When you're finally done, and you upload this to JLCPCB, where they're going to manufacture it for you, they give you like a nice little 3D view with all the components. And you see here that some things are wrong. These 2 connectors, they're not aligning with the drawings it has on the bottom. So in this case, I need to rotate it twice. Even if you do all the work of getting everything right, you upload it, and then the thing interprets it in a different way. This is the TVS diode. This is the one that protects against the fat finger that sparks in the USB port. It has a plus and a minus, and it's a diode. Diode is like an LED, it has current going through it in one direction. And so I looked at it, and it says plus and minus on JLCPCB, and it's the other way. I'm like, that's wrong, I need to rotate it. It turns out I was wrong. And if this would have been manufactured that way, then every time I plugged it in, it would have just been a short circuit and nothing would have worked. I was smart and I ticked the box that says, let an engineer double check your thing. And the engineer at JLCPCB actually rotated it back to the correct orientation. If I did not have that, I would have wasted like $170 ordering this. This is the kind of stuff that you're dealing with
no pressure. Good luck. I have not been so nervous in a very long time. These are the PCBs. Manufactured, assembled. And I have no idea if they're gonna work. This is gonna be 170 bucks of expensive nerdy wall art, or will this actually be the real thing? I don't know, man. Oh, dude, look how cool this looks. This is actually very, very small. The whole thing. I swear, mine is bigger. I swear it's not this bad. But technically, I should be able to program this and then turn it on and off over Wi-Fi. I flashed it, and now it just shows up. I can connect it to my Wi-Fi, and my home assistant found it. What? It actually works. And I can... Damn it. Oh. I'm a little bit speechless. I'm just a random dude, man. I just asked Claude how to make this and then sent it to manufacturing, and now it's connected to my Wi-Fi and I can turn it off and on automatically and got what I wanted. Next thing, of course, I need to build the actual enclosure. But this whole thing actually started because I was looking at 3D printers and I saw that Bambu has one for less than 200 bucks that is apparently good and easy to use. So I'm like, okay, then I buy a 3D printer. And that's how this whole thing began, because it unlocked the ability to have my own case for my light. I created the 3D models to print in Autodesk Fusion, which is a whole new thing to learn as well. The thing about how this works, and any computer-aided design software, is it's not like you're drawing something like in Photoshop, and it's also not like you're programming something. It's in between the two. This works around what they call constraints. For example, well, the distance of this USB hole should depend on the thickness of my circuit board, right? Because it's some distance from the bottom, which is the distance of the screw hole, then there's the thickness of the circuit board, and then there's the size of the USB-C hole. Every single step you make matters. It creates a timeline, and if you set up the dependencies between the things correctly, this means that you can go back in time. Let's say I switch to a larger heatsink, and then all of the things adapt to that. The cylinder becomes bigger, but the circuit board still lines to the edge of the case. The height of the thing is still correct, and all of these other, like the screw holes, are also at the right place. But that only works if every step you make is correct. Plenty of times you build something, you need to change it, and you see that as soon as you make the change, the whole thing flips upside down and inside out, and you're like, have to build it again from scratch. Pretty much all of the constraints in Fusion map to things in the real world, like the diameter of my heatsink, the size of my circuit board, but also the screw holes. These are threaded inserts. You melt them in the thing, I'll show you later, and then you can screw inside so that you can screw in and screw back out. And we like screwing, so it's good if you can do it a lot. You put these measurements correctly in Fusion so that when you put it in, it's not too sloppy and it's not too tight. It's just right. One of the big design challenges for the case is, how do we build this around this heatsink? First, I made like a bottom with some notches, and so it goes in here, and then it kind of, you see, it's still super loose. It doesn't work. So I'm like, okay, how do we do this? At the end, I came up with a design that we have a bottom, it rests on it, and then it kind of wraps around into these fins. And because I made it nice and tight, you kind of squeeze it in and it holds it there. But I wasn't trusting it enough, so I added another ring on top that screws into the side posts, and that you can screw it down, and that really solidly holds it. Something I wasn't sure about is, how do I shape the lampshade? Because I wasn't sure, I thought I would design a system that allows me to switch the lampshades.
So if you see here in Fusion, this is what the top looks like of my heatsink cover. And there's the screw that connected to the part below it. And then there's a detent, and then there's a little hole. These two work together to help attach the top parts. On the opposite side, the shade itself has a little hole where this notch sticks out. And the shade also has a hole opposite of this hole, because in here and on the other one, I'll put in magnets. That makes it so that when I put the shade close to it, it snaps into place. And then the notch that sticks out, the detent, makes it so that it doesn't accidentally like rotate or shift around a little bit. Now comes the messiest part of the whole thing, because you need so many little things for the final assembly. All the components are here, now we need to put them together. So I've got this case in the underside. I've got the heatsink. On the heatsink I need to connect the LED PCB, and on the LED PCB I need to solder the actual LED, and between those things I need to connect heatsink paste. In the casing I have 3 at the top and 2 at the inside, threaded inserts, or holes for the threaded inserts. The way you connect them is you take one of these, you put a soldering iron with like a specific top, you put it inside the threaded insert and you melt it through. So you melt the plastic very softly, very straight, and then you just kind of take it back out when it's on the right space. Then I would put in the circuit board, and now I need to connect the 2 last pieces, which is 1, the actual LED, and 2, the button. I found this button on Aliexpress. It's really nice. It's like metal, you click it, very satisfying, and it has a little ring around it. It came with this cable, and at one end it was just wires. Now in the PCB I had put a JST connector. I actually put the wrong one. I wanted a smaller one and I put the big one, but that meant that I had to buy a box of the big ones, and you have to crimp these. So if you have this cable, it comes with this strip of little, I don't know what they call this, but you cut one off and then you put it inside this very specific thing, the crimping tool. You put it here, you put the cable through it, and then you push it down. That's pretty much all for assembly. So if you can see here, this kind of, it pushes in tightly, so it does stay, which is very nice. But I still have this other ring that I put on top and I screw down to hold it tight. And once that's done, it'll look something like this. This one still doesn't have a button yet. But you see here that this top, it stays on, but I can also very easily take it off. And this is because of those 3 magnets that I pushed in here. This also allows me to switch between different types of shades, because I'm still not sure what I think is the prettiest. What's the cost of this, you ask? It's about 45 euros per light. That's not cheap, but it gets me something that I cannot get anywhere else. Most of the cost is from the PCB, and in the PCB most of the cost is from setup and shipping. So if I would do this in larger quantities, the cost would go down significantly. But right now, I paid 50 bucks and I got the absolute perfect light that I wanted. So let's have a look. So here we have it, my own little cozy light. The light is absolutely beautiful. Enclosure looks nice. We have a very satisfying button that goes off and on. I even have flame mode. If you double tap it, it starts flickering a little bit. This is connecting via Wi-Fi to my home assistant, so it goes on when it gets dark and it goes off together with all of the other lights. It's not perfect, so there are a few things that I need to change in version 2. There's actually one I still need to fix right now. When I added the lampshade with the magnets, the Wi-Fi connection got very spotty. So I actually need to remove the lampshade before it can connect to Wi-Fi, and then still it kind of drops sometimes. So I need to figure out a way to do this without magnets, or maybe make the top higher so that the antenna is further away from the actual magnets. And then when I check with my camera, I do still notice some flickering. I think the flickering is too fast for it to be a negative impact on us, but I really want this to not flicker at all, and it is still flickering a little bit. So I think in the second version, I will update the PCB to have another filter on the output signal so that there's absolutely nothing possible and it smoothens out this flickering. There's no on and off at all anymore. So, man, what an adventure. What an adventure. So much lessons learned, and along the way we made something very beautiful. If you have something that you want to exist in the world and it does not exist, go build it. The world's your oyster. This stuff, all of this is not made by people any smarter than you. You can absolutely do it with some perseverance, with some effort. But that's, I mean, what else would we be doing? Thank you for watching, and I'll see you in the next video.